Hey Martha, I'm making a little movie for you. Dolly and I talked with Patrick about one of the experiments that we've been working on human embryonic stem cells and PM NATO3, and we wanted to touch base with you about what you thought about a funding strategy in terms of where we should maybe go to take some of this data and energy or effort that we have so far. So I'm going to kind of cap it a bit, but Patrick, the main idea is Patrick thought maybe this could be good for an RO3, but maybe there's not enough data, so that was the concern. But then what we're looking at basically is the question and the endpoints that we're looking at is basically can PM NATO3 drive human embryonic stem cells to become dopamine neurons? Could it increase the efficiency or the rate of differentiation of those neurons? So that's the idea. Can we do that in culture with these cells? And the data that we have so far, we're approaching this question here, and we should have an answer probably in about 40 days, I'm hoping. But we have some other data too that might be useful. So even if this doesn't quite work the way that we want, maybe we're in a spot that we can go ahead and start thinking about how we can get more funding to be able to help get to these endpoints. So the data that we have so far is looking at when we've coupled this pro-neural factor, neurogenin-2, along with PM NATO3 in human embryonic stem cells, and then with standard differentiation conditions, not dopamine-specific ones, but standard ones, we've been able to see some TH increase. And then another thing where we actually turn on PM NATO3 plus these dopamine neuron differentiation factors to see what happens to these neuronal, and we see these neuronal-like cells that appear. So we're hoping that we have some data on that soon to help give us more insight into it. But the reason we're talking about this is because we need to strategize about the funding, as I mentioned before. So let's take a look then at what we've got. What we did is we have driven PM NATO3 in human embryonic stem cells, and we made stable cell lines that basically have both the neurogenin-2 and PM NATO3 under a TET-on promoter. Then we plated those cells, added doxycycline, and then so that it's in this E8 media. Then we switch into 3M media, and then we remove the dox at day 9, and then we allow it to differentiate. And so what happened in that case was that if we look at just TH, this period right here is where we have PM NATO3 being expressed, and then TH pops up and stays up, and then at the later stage is actually quite high. So that's one thing that's happened there. And then if we compare that to our control condition, which is this cell line that expresses neurogenin-2 but does not express PM NATO3, you can see that there's a difference. So presumably, when you overexpress neurogenin-2, they tend to become glutamatergic, or somewhat GABAergic, but I think mostly glutamatergic. And so what you're looking at then is that perhaps the NATO3 is actually tuning these cells to start to express tyrosine hydroxylase, especially at these later stages of differentiation. So that would be really cool, but not all factors are working that way. Like Neuro1 looks like it goes up and then it comes down again, so that's a bit weird. And if we look at what we get from all of them in terms of this column is showing for different markers like Sonic Hedgehog, FOXA2, LX1A, etc. So Sonic Hedgehog went up, Ingrail1 went up, Neuro1 went up, but then drops, and then TH went up. But other ones like FOXA2 did not go up, where we would have expected it to go up. So these are some issues that we're, so clearly PM NATO3 plus neurogenin-2 doesn't necessarily, isn't sufficient to make dopamine neurons. But we wanted to try it. The Sudoff lab is the one that actually does that sort of speedy neuronal differentiation with human embryonic stem cells. And so we were following what they did. So then what we wanted to do was basically say, okay, well, what if we put it in the context of all the media types of conditions that would allow dopamine neurons to normally appear? And so we used 2 different kits to do this, and there's a long story why, but basically this is the first kind of kit that we used. Specification, expansion, and maturation medium that we got from Thermo Fisher. And then over time, what we monitored to see what happened with these different markers. So a lot of optimization was going into this and just trying to make sure that we were doing it right. And we were working with the U of M's stem cell core to do this work. So here we had basically 3 questions. Can we replicate the dopamine neuron generation with the Thermo Fisher kit? Can we? And then one thing we were curious about is what happens to NATO3 as it's expressed in vitro. And then finally, we wanted to induce the PM NATO3 docs with media. So that kind of increase in efficiency or rate of differentiation. So we never got to part 3 because it was back ordered for months and months. So we had to switch kits. But I can answer the first 2. So, and what we saw basically was that we could get dopamine neurons, and we talked with Chris McMahon over at CDI, Fujifilm, to see what they liked to see as a endpoint for their studies. And so we used the antibodies that they recommended, and we used the qPCR markers that they recommended as well, just to try to make sure that things that we were doing were interesting to them, because this could be potentially a commercializable tool. And so these are just pictures showing that we have FOXA2 and tyrosine hydroxylase co-expressed in these cells, and then TUJ1 and what's going on with NER1 and FOXA2 as well. So that's there, and we got that working. So we're pretty happy, and we're ready to get started on going into activating the doxycycline. And then we ran into some issues with supply chain. But one of the things that we did find that was pretty interesting was that it looks like NATO3 increased over the course timeline of differentiation. So, like as we see in GRAIL1 kind of popping up at these later stages here, we also see that NATO3 is popping up at these stages as well. So these are just 2 different rounds of differentiation that we did. I think it was round 1 went up to like 36 days or so and showed an even higher induction there. But these were the directly comparable time points that we had between the 2 rounds, and so we just wanted to show that. So that's kind of interesting as far as a data point, but wasn't allowing us to really get to the key question. So then we went back, and we had to switch kits, and so now we're in this, and now we're into this stem cell technologies kit. So this is a little bit different in how it's set up, but basically what we wanted to do was to go ahead and work from embroid bodies and then plate them out, and get the rosettes and then passage them and differentiate them so that we were able to actually generate dopamine neurons. And so what we did then is and then we collected at these different time points. So this experiment ended up having to stop at day 11. They had some issues with the control condition, but they still saw some interesting data with it. So we're hopeful that on our next round we'll get something more interesting. So just as a point of note, what we see here is our, if you remember, I told you I had a stable cell line that co-expressed neurogenin-2 and PM-NATO3 under the expression, under the TET-on promoter. We made another stable cell line. This one actually just had PM-NATO3 on it. So that's the one that we ran through this sequence with. And then as a control, we had just the H9 cells, no doxycycline, just the H9 cells. So it's a bit of an imperfect control, but this is the first time that they were using this kit, and they wanted to try to make sure that they were able to see dopamine neurons at the end. And anyway, so we'll take a look at this. So after adding the doxycycline, they basically have plated out these cells. And then I'm going to zoom in on the NATO3 condition that looks different than the H9 condition. And on the edge of these rosettes, what they're seeing that's unique is that they see these kinds of processes coming out of these cells here and also over here. And so the idea is that perhaps what's happening with, and this is PM-NATO3 down here, that kind of thing you don't see in the H9 cells here or over here. So they look like they're moving out, and like they're kind of coming off of the colony here. So there's some migratory, perhaps, phenotype that's associated with it. And then we're also seeing these sort of neuronal-like structures here. So they're excited. We're in the middle of actually doing qPCR and ICC on this to try to, confirm or see whether we see anything interesting there or not. But it could be really cool. So that's where we are with that. This is essentially kind of a similar picture, but looking at day 8. So what is it then that we want to do, and what is it that we're trying to think about as far as issues and next steps? So as I said before, we kind of been playing around with these different kits. It's been kind of frustrating because we had the supply chain issue went right when we wanted to do the key experiment. So now we're setting up to do the key experiment again. with a stem cell kit. So we'll try it plus or minus doxycycline and then watch and see what happens as far as differentiation is concerned. We'll also process that data that you see here, because we just saw this data yesterday, and see whether there's something with this NATO3 condition, PM NATO3 condition, perhaps that's indicating that there's premature differentiation. And that would be really interesting if we saw that, especially if they were dopamine neurons. So we've got some of this data here, and we'll see where these endpoints take us as far as the next round of funding. But I wanted to think ahead about where we want to actually apply for the next round of funding, what types of endpoints do we need to reach in the experiments that we have ongoing, those types of questions, so that we can be in the best position to finish or make the most of the money that we have left. So the question that I'm seeing is basically, do we see any, one is like, do we see any increase in dopamine neurogenesis genes in human embryonic stem cells? That's what I'd like to see out of these data here. I think for an R03, what we want to say is, going back to what we had talked about at the very beginning, do we have an efficiency? Do we have, in terms of greater numbers of FOXA2 positive cells? Or do we have do they come up faster? And does the rate of differentiation more quickly? Sort of like what we're hoping that we're identifying here in some of these phenotypes at these different days. So perhaps that's the case. And so we will... So that's kind of the endpoints. When we were talking with Patrick, he had added the endpoints that at least, it would be great, good to show dopamine synthesis, like internal dopamines within the cells, and then also dopamine release induced by potassium chloride. And in addition, being able to look at at transplantation. And so for an R03, I think transplantation is out of the question given the scope of funding that we have with it, but I think we might be able to do something else. So, so I think the other endpoints, I think we may be able to add to it. So right now, what I'm seeing, our next steps are, we're gonna try this, or we're gonna do this experiment again, see if we get some nice data that we can actually include in there. And there are some other experiments of trying to see if we can actually just show proof of principle. Okay, PM NATO3, can it drive specific dopamine neuron markers or not? And so the idea is basically, maybe trying for an R03 and seeing if we can have sort of a methods-based or a very sort of circumscribed set of data, rather circumscribed set of experiments to be able to address this. So the question is, do you think that's viable? Do you think that's actually like a real goal? Let's pretend that this data is a little wonky. There's issues with it. And I don't know how it's going to go, but just life sometimes throws these different curveballs. So, how do we want to approach this if it's possible? So one thing we can do is we can put in some of the data that we have from from PM NATO3 in the chick. That stuff is not published yet. We've just got one paper out on the wild type NATO3, but nothing on the modified one. So that'll be sort of preliminary data that we can include in this R03, along with some of this data, and perhaps that will carry the day. But I guess we wanted to kind of get a sense of what your thoughts were on that. So I think I've chewed up enough of your time. Thank you for your thoughts. Bye.